Thank you for giving us your attention. I am Mara Menegon, and I developed, together with Ruggero Rangoni, who is sitting there, an agent-based computer model of the evolution of the private property norm. Okay, first of all, I will introduce the concept of endowment effect, which we believe is closely related to property norm and its evolution. And then I will, I will briefly introduce our model and explain how it works and show some of our results. This is still a work in progress, so suggestions are welcome. Okay, let's start from the endowment effect, which has been named so by Richard Thaler. And the endowment effect is a bias which leads people to value a thing that they own more than an identical thing that is not in their possession. Several experiments have measured that that owners value a good that they own twice or more than 4 times, the current value of that thing. So we can formalize the endowment effect as a coefficient that multiplied by the current value of a thing gives the subjective value of that thing to its owner. Okay? Endowment effect leads to loss aversion, which is the tendency to prefer avoiding losses to acquiring gains. Okay. And endowment effect has been widely observed in nature among adults and children and among animals. For example, butterfly, horses, great apes, and wasps, for example, and many more. All these experiments concerning animals implies that endowment effect is related to property norm. Okay, property norm is simple, the widespread respect for ownership. And it is almost always observed in nature, where the owner retaining her possession in more than 80% of territorial disputes among animals. Okay, in game theoretic models, property norm is explained, first of all, as a pure equilibrium, which means there isn't any fight, and property is never stolen. And it is conceived as a convention alternative to anti-property norm, which is the state of affair in which property is always stolen, and which is hardly ever observed in nature. Okay, we believe the endowment effect could be the key to property norm, as has been stated by Gintis. They are both almost always observed, and since endowment effect leads to loss aversion, biased agents by the endowment effect are more willing to fight to defend their property than to attack other property. And since the expected defensive effort of owners is greater in a biased population, non-owners will attack less since they expect a greater effort from the adversary and then a greater injury. So, in a population of biased agents, there will be less fight and then less injuries and then a greater agent's fitness. And in a population of biased agents, probably the property norm would emerge. And what's more, the endowment effect does not explain anti-property norm, since a negative endowment effect is not plausible, because agents would behave like a money pump. If I like more the thing that you own than the thing I own, then I would give you mine for yours, and and this would be a never-ending circle. Okay, let's come to our agent-based model, which we developed using NetLogo. And we developed this model expecting that endowment effect will reduce injuries and increases payoff, as I have explained, and that given a simple evolutionary mechanism, endowment effect will invade the population starting from a small number of biased agents. And in a population of biased agents, property norm will emerge. And this property norm will be not a pure equilibrium, which means there will be some fights and property will be sometimes stolen. Okay, how this model works. Each round, a fraction of agents own a property, and each non-owner, which we will call an intruder, chooses an owner to attack. Intruders and owners choose their convenient effort in the fight, basing their choice on the neighbor's effort in previous fights. There is the expected effort of the adversary, and the value of the property, which has greater weight in biased agents since it's multiplied by the endowment effect coefficient, okay? And the risk of injury, okay? If the intruder wins, she steals the owner's property. Okay, the chance of the owner winning the fight is proportional to the owner's defensive effort and inversely proportional to the effort of the adversary. Okay, and if attack or defense are equal to 0, there isn't any fight. Otherwise, the agent's chance of getting injured is proportional to the average value of attack and defend. We have drawn these equations from Ginty's The Evolution of Private Property Norm, which is of 2007, The Evolution of Private Properties. Okay. And agents get their payoff, earning the value of the property if they acquire or retain it, and if they are injured, they lose the value of the injury. Okay, our evolutionary mechanism is very simple. It's an evolution through imitation, in which agents imitate the endowment effect of their neighbors that gain the maximum payoff. And there is a chance of mutation. Okay, let's see some of our results. In this graphic, we can see how a greater endowment effect increases payoffs and decreases injuries and increases the chance that the owner wins, which is what we believe illustrates the property norm equilibrium, since what we observe in nature and we call property norm is the state of affair in which owners usually wins the fights for possession. Okay, in this graphic, an endowment effect equal to 1 means that there is no endowment effect at all. The coefficient is 1, then owners value their property equal to its current value. While an endowment effect equal to 15 means the owner value their property 15 times its current value. Okay, here we can see that varying the value of the property, the average payoff of biased agents is always greater than the average payoff of the rational agents, except for the 2 limit cases when the property value is very low, which means it's always worth fighting. No, it's never worth fighting if the property value is very low. And the opposite case in which property value is very high, then it's always worth fighting. Then there are a lot of fights, and then a lot of injuries, and then a smaller payoff. Okay, here we can see how evolution gives some results. starting from a population in which 1% of agents are biased, the number of biased agents rapidly increases, and it increases also the average defend, which is the effort of owners to defend their property, and decreases the average attack. It also increases the chance that the owner wins. Okay. So, a brief summary. Our results have shown that if evolutionary mechanism is triggered, endowment effect rapidly invades the population, leading to increasing payoff. And that in a biased population, property norm is respected, which means owners usually win the fights. And property norm is not a pure equilibrium, since sometimes property is stolen, and our results are robust under changes in the parameters, as we have seen by varying the value of the property. Okay, these are some references. And that's all. Thank you for your attention.